Mr. T here with another calculus tutorial. Today we're talking about the quotient rule for derivatives. The quotient rule is used for finding the derivative when we have a function which is consisted of a function divided by a function. Now both of the functions in the numerator and denominator must be individually differentiable. The rule is shown over here. So we take the denominator times the numerator prime minus the numerator times the denominator prime, and that's all over the denominator squared. Putting it over the denominator squared is going to be something many of you will tend to forget. So let's not do that. So let's look at an example here. And we have our function here. And just note that we could not solve this using our basic derivative rules, because since we have an expression with an addition here, we can't divide out. So we need to use the quotient rule here. Now the top function here is our u of x, and the bottom, the denominator, is our v of x in our formula. So let's expand this out using our formula here we have at the top. So we take v of x, the denominator. Now we need to take the derivative of the numerator, so the derivative of that is 1. Now we have minus part of the formula. Now we need u of x, that's the numerator, and times the derivative of the denominator, which would be 2. And that entire expression is over our denominator squared. So now we need to simplify the numerator, so we are going to distribute and combine like terms. So on the top we have 2x plus 3, and then we have minus 2 times x, so we have minus 2x, and we have negative 2 times negative 1, we have plus 2. Our 2x's in this case cancel out, so on the top we have 5, so our derivative is 5 divided by 2x plus 3 quantity squared. So that would be our final answer for this problem. Now remembering this formula can be a bit tedious for some of us that have trouble remembering formulas. So on our next example we are going to look at a way you can arrange the problem to help you remember the formula. So let me set that up. So here we have our second example. We have our u of x on the top and our v of x on the bottom. Now the top we need to do some rewriting to make that differentiable, so we can move that x to the numerator, and now we have the denominator. So again, this is going to be our u of x, and this is going to be our v of x. So to set this up, sort of like we did with the product rule, we're going to write our u and our v. Below it we're going to take the derivative of each. So here we get negative 1 times negative, so we get plus 1 x to the minus 2. And here we get v prime is 1. Now to make this work on the quotient rule, since there was a minus, we need to take the opposite of whatever the v prime is. So I need to take the opposite of both sides of the equation. And now we're going to cross multiply. Now if we wanted to match the rule formally, we would go this direction and that direction to get the minus, but it doesn't matter since we put the minus here, so we can cross multiply in either direction. And now that we're taking the derivative, our function is called f prime of x. So we have here 3 minus x to the minus 1 times minus 1, and then plus, now we do this derivative, that direction on the cross multiply, x to the minus 2 times x plus 5. And it's still over, you still have to remember to put it over the denominator squared. So now we need to simplify our numerator, so we're going to distribute property first. So we get negative 3 plus x to the minus 1. And when we distribute here, we get x to the minus 2 times x is plus x to the negative 1. and plus 5x to the negative 2, and that's all over our denominator squared. Now we have to well, we're going to combine those two together. I'm just going to show that here. So we've got 2x to the minus 1 here. So now we have to GCF factor on our top. So our GCF, if we look at our coefficients, there's no common factor. And for the x, our smallest exponent is x to the minus 2. So we're going to factor out an x to the negative 2. So if I divide this, I get negative 3x squared. And when I divide this, I get plus 2x. And when I divide here, I get plus 5. And that's all over our x plus 5 squared. And now all we have to do is move that to the denominator for our final answer. And our final answer is now negative 3x squared plus 2x plus 5 over x squared times x plus 5 squared. And that's our final answer. So you can either memorize your formula and plug in, as I did on the first example, or you can memorize the pattern for setting up, or we set up u prime, v prime, and then remember to take the opposite here, cross multiply, and put it over the, you still have to remember to put it over the denominator squared. So good luck in your deriving.